Welcome. We're up to grade 6, part 5 of the Show You Work Hardest math problems. There's a link to a whole bunch of other videos at GregsTutoringNYC.com/hardest-math, arranged from grade 3 to grade 8. Not only Show You Work, but multiple choice versions as well. Plus, I have hundreds of other videos on my channel that you guys should check out. All right, so these go about an hour each. So let's jump right into it this time. Okay. Over the years, I've noticed these kind of problems are kind of extra uh, annoying to students. They do even worse. So I'm going to actually skip 39 and probably spin that off by itself. Okay. Not probably. That's what I'm going to do. So I'm going to start with number 40. Abdi has 2 electric trains, A and B. Okay. Each train is on its own circular track. So A has a circular track and B has a circular track. May not matter. Let's see. He starts both trains at the same time. So if you will, they start right there. Okay. Train A returns to its starting point every 12 seconds. So in other words, it goes around 1 revolution in 12 seconds. Okay. Do this visualization, guys. Write it out and draw it out. A big thing is writing and drawing. Okay. There's a yin-yang between what you should do in your head and what you should put down on paper to solve problems. Things that are numeracy issues, no hesitation math, that kind of stuff, like 12 times 10, there's no point writing that out. But something that's going to end up being a gotcha, including overloading your short-term memory, you should write or draw out. Okay. Train B does every revolution once every 9 seconds. Okay. You should already know at this point that this is probably a GCF, greatest common factor, or least common multiple question. Okay. They're often set up this way. Not always, is not a guarantee, but that should be a hook that there's two things kind of being compared, and you can almost guess what the question is going to be once you're familiar with it. So if the trains can keep traveling, in other words, they keep going around and around their respective circular tracks, what is the least amount of time? So that's another clue. It's not a guarantee that this is probably the LCM. Okay, in seconds. So that was in seconds. That was in seconds. So there's no unit conversion. Okay, that both trains will arrive at the starting points at the same time. So what it's trying to say is, for instance, if A went around the track 5 times in 60 seconds, then would B be back to its starting point in that same 60 seconds? All right. So we need to least common multiple. What number is a multiple of both of these so that they line up together? Another way to visualize this is if this was on a linear track, not a circular one. Okay, and let's say it went into infinity, and B also had a linear track that went into infinity. Okay, if A is every 12 seconds, that's 12, that's 24, that's 36, etc. So this would be every 9, 18, right? 27, etc. 36. So we notice that matches up. That's one way to do the LCM. All right. You can set up if A is by 12s, and it's 12, 24, right? 36, and so on. All right, stuff like that. So B would be 9. There's no equal numbers. 18. There's no equal numbers. 27. There's no equal numbers. 36. Ah, that's the first number that matches up. So this is the least common multiple. These are multiples: 12 by 12 by 9 by 9 by 9. 9 times 1, 9 times 2, 9 times 3, 9 times 4. 12 times 1, 12 times 2, 12 times 3. So they're multiples of each respectively, and 36 is a common multiple of both of them. And it's the least one, and that's what they asked you to do over here. So that's where you get the 36 from. Now, if the number was larger, it could get into a very large number. This can get kind of tedious. Some of you guys also know how to do this with prime factorization. So if you took to 12, and I did another one of these a couple of videos back, 2 and 6, and split this up with the prime number 2 and 3, okay? If we took, what's the other one, 9, that becomes 3 and 3, okay? So this is 2 squared to the third, right? And this is 3 squared, all right? So what you want to do is take every unique thing. We have a 2 squared here, that's the most. There's a 3, so we can add the 3. However, this 3 squared trumps that, so this becomes 3 squared. So we get 4 times 9 equals 36, okay? That's one way to do it. This is not a teaching session to teach you prime factorization. It's not also to teach you least common multiple, right? So that's not the intent of this session right now. You guys should know these things. There's another technique to do both of them simultaneously that many of you might not be familiar with, which is to just list the two numbers, 9 and 12. Okay, find the smallest factor of both that divides into both of them. That's a prime number, so that would be 3. So we get 3 into 9 3 times, 3 into 12 4 times. All right, we're only left with this. We can't divide 3 into 3 and 4, and we can't divide 4 into 3 and 4, and we can't even divide 2, so we're done. So what we want to do is take the L shape, go down here, and then go across. So that's 3 times 3 times 9. Times 4. And that's equal to the 36 again, okay? So this technique a lot of you guys may not know about, so it's something you should do. And the GCF one is just the column going down here. But if you can make this L shape, you can get the LCM fast, and because there's some questions where you have to get the LCM and the GCF simultaneously. But to me, this is more precise than doing it this way here, and it uses less space on the page than this way here. We're trying to sometimes solve problems efficiently. Okay, we need to do that in the real world. It needs to be correct, obviously. We're not just doing this fast for joys. All right, so that's the answer. We got 36 this way. 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 So really my intent was to show you this technique more than anything. Okay, and I like it. It's super duper handy. It's more accurate. It's less sloppy. Not only does this prime factorization technique, which works perfectly, you have to make sure you didn't make a mistake here. You have to normally copy these. You have to do the comparison, right? This thing with the L shape is just easy peasy. Anyway, the first thing is to know that you need the LCM. So once you see that you're trying to compare two numbers that are repeating, right? If the trains continue traveling, they keep going around in the circles, okay? What is the least amount of time that they will both arrive, okay? And you can test that, right? You can test that A would go one time, a second time, and then a third time, and 36. Where B would go 9, 18, 27, 36. So they would both meet at the top of their things, if you will, at the same time. We could have even done track A for A, which was larger, and put track B inside of it like that. And they would have actually both been on tracks next to each other at the 36-second point. Okay? All right. So this was a word problem, sure. It just begged and leaped out at you to solve the LCM when you see something structured like this. For sure, it's almost always going to be the LCM. And then there's the actual implementation of how you did the LCM. No matter which way you did it, you had to get the right answer. So it required mild multiplication pretty much in each example, no matter how we slice it. We're just getting multiples of 9 and multiples of 12. All right? And again, we just want to be sure we have our units right. Okay, 41. Winston's earned about $140. selling 56 hot dogs, okay, at school, okay, using the same rate. This is a rate, $140 per 56 dogs, okay. How many more dogs would Winston need to sell to earn a total of $875, okay? So one way is to straight up set that up. If he was to make 175, how many dogs does he need to sell here? Okay, so we can do the cross product. We get 140D equals 56 times the 175. And to get D by itself, we're going to divide this side by 140. Whoops, 140, not D. And I'm going to divide this side by 140. All right. Instead of doing this nasty multiplication, in other words, you can have to do 175 times 56. And you can go ahead and do that. I like to think that when they give problems like this, that there's often a way to do that. And I notice that 15 times 2 is 28, and 28 times 2 is 56. So that means 14 goes into 56 4 times. 14 goes into here 10 times. In fact, 28 went in. 20. So anyway, if we do that one more time, right, 2 goes into here twice. Come on, write that. And 2 goes into here 5 times. Okay, and now we have 5. We can divide 5 into 175, right? We get 5 into the 3. 15, we got 2 left over. So we get 35 is the answer. Everything canceled out. Look at this canceling out aspect happens fairly often. Okay, and it's something we can kind of strive for and get at. And there's one last part. I said everything canceled out, but we still have this 2. So that's going to be times 2. And that's equal to 70. Okay. So now we have our 2 numbers. We have 70 under the scenario where he makes $175 and 56 under the scenario that he makes $140. So the difference there is going to be 14 hot dogs. Okay. And if you look down here, the answer should be in hot dogs. There we go, okay? Okay, and again, for those who want to do as an exercise for the reader, you can do it this way with the nasty multiplication and then divide by 140, whatever that result is. Let's call that x. Then we're going to do 140 goes into whatever that x is. Okay, and you should get the 70 back there as well. All right, let me change the color of the ink for a second. In fact, I'm going to go do that. So you have 175 times 56. 6 times 5 is 30, 0, 3, 42, 5, 4, 6, 10. Okay, 5 times 5 is 25, 2, 35, 36, 37, 3, 5, 8. Okay, so we got 0, 0, 8, 9. Okay, I'm assuming I did that correctly. Let's, if I can divide the 140 into there, then I did. Okay, so that's 9, 8, 0, 0. Okay, we already know that it should, the answer is going to be 35. Or sorry, the answer is going to be 70. So let's try 7 here. 7 times that is 0. 28, 2, 9. Isn't that wonderful? We get 7 and there's nothing left over, so we get the 70. Oh yeah, oh yeah, oh yeah. Okay, there's another way to still do this, which was to kind of take it a step at a time. If we go to the original problem, which was $140 and selling 56 dogs, and we actually do that division, we could do it on the side. 56 goes into 140. Okay, we're probably going to need decimal points here, or at least fractions. 56 goes into 1, no. 56 goes into 14, no. 56 goes into here twice, it looks like. That gives us 112, right? And we are left with what? 28. The decimal point goes up. You should know 56 times 10 would be 560, and 56 divided by 2 is that. So this must mean it's 5, whereas 10 divided by 2 is 5, right? Catch that on the replay. If 56 times 10 is equal to 560, and 560 divided by 2 is 280. These are the two operations we did. Times 10 divided by 2. Times 10 divided by 2 is the same as multiplication by 5. So 56 times 5 would be the 280. We get 2.5. Okay, the 2.5 represents $2.50 per hot dog, okay, from the original problem. Okay, so if in the second, using the same rate, so the same rate is $2.50 per hot dog, how many more dogs would he sell if he did $175 worth? So we have to divide 250 into 175. Okay, so we can go on the side and do that. 2.5 into 175. So we're going to move this once, and we're going to move this once. We have to have a 0. So that means we now have 25 into 1750. Okay? Yeah? Okay. So 25 goes into 1, no. 25 into 17, no. 25 into 175, that's going to be 7. You guys should know that on like 25 times 4 is 100, and then 25 times 3 is 75. Just try to use money. When you see a quarter or 25, just think of quarters as in coins. And you can do the math a lot easier that way because we're used to doing numerical math, getting change and paying for stuff and things like that. So you shouldn't have to go on the side and figure out what 175 divided by this, and then there's no remainder, and we get that. So we get back our lovely 0 again. So this is equal to 70. Okay, and we get back to 70 there. We still have to come back now and do this here. Okay, in both scenarios we have to do that. All right, so the answer here would be 14 hot dogs. Don't get caught up in the complexity, no matter which way you did this. Don't get stuck that the answer is 35. Don't get stuck that the answer is 70. Don't get stuck that the answer is 250. Okay, you have to follow through the whole problem. And instead of going to the next problem, go back to the word question and reread it. That's a sure way. And double check, re-underline stuff, give things a check mark. I did that, right? So that you're kind of on board and you're kind of following yourself on some of this. All right, so that was 41. 42 is another word problem. So at the end of a baseball game, the players were given the choice of having a bottle of water or juice box. Of the players, 12 chose a water bottle, which was 3/4 of the total number of players. So 12 are 3/4 of the players. Write and solve an equation. Well, I just wrote it to determine P, and I used P already, so that's cool. So I'm on sync with these people. So that's my equation. 12 is 3/4 of all the players. Okay, So that makes sense. The English maps to the math, and the mathematics back. Okay, write and solve an equation to determine the number of players. So now we have to actually solve this. So we're going to multiply this side by 4/3. Why? Because this will cancel out. And we're left with p. And so therefore we're going to multiply this side by 4/3. You can get 48 divided by 3. And most of you don't know that that's 16. You're supposed to know this. Again, know your multiplication table up to 20 by 20, especially with these extra things. The other thing you could have done was 3 goes into 12 4 times, and gotten 4 times 4 is equal to 16. All right, so this one wasn't such a baddie. Okay, so then P is equal to 16. Okay, 16 what? What are the units we're trying to shoot for? Players or water bottles, right? 12 chose the water bottle, so it's not water bottles. We're trying to figure out from the number who chose it how many players there actually were. And if we go double check it, if we do 3/4 of 16, right, we can get 48 over 4 again. That's equal to 12. We also could have put the 4 into here and got 4 times 3 and still get the 12, all right? So we can get our answer back. Always double check, replay things in reverse, do the reverse operations, etc., yada, yada, blah, blah, blah. Okay, so that's our deal for 42. Okay, Tristan is comparing two numbers patterns based on the information below. Both patterns start with a number 1. Okay, so this pattern A, it starts with 1. Pattern B, it starts with 1. Okay, pattern A follows the rule add 3. So if I add 3, I'm going to get 4. Okay, if I add 3 again, I'm going to get 7. If I add 3 again, I'm going to get 10. Oops, I should write the 10 down there. So I have 1, 4, and 10. B says add 4. So if I add 4 to this, the next one I'm going to get is 5. If I add 4 to 5, I'm going to get 9. If I add 4 to that, I'm going to get 13. So let's see what it says. How do each of the 5 terms in the pattern compare? All right, so I did 3. So let me write this out neater. So A is going to be 1, 4, 7, 10, and 13. Okay, B is going to be 1. We get add 4, so we get 5, 9. What does it add 4? 13, and 17. Let me just make sure I did this. Sometimes some of the easiest questions is the ones where you're going to goof up on. Plus 3, plus 3, plus 3, plus 3, plus 4, plus 4, plus 4, plus 4. Okay, cool. And then it says, how do these patterns compare? How does it compare? List, and then it demands that we list the first 5 terms. Okay? So the comparison seems to me, the difference between 1 and 1 is 0. The difference between 4 and 5 is 1. The difference between 7 and 9 is 2. The difference between 10 and 13 is 3. The difference between 13 and 17 is 4. So the comparison is for each respective number in a term, it goes up by 1. And that's all you need to explain. All right? So if you did the patterns correctly, you're going to get, that's part of your thing, and the explanation is the other. All right? So 43 is kind of clear. This is not a least common multiple problem. In other words, this 13, the answer is not 13. Okay. Similarly, we're not looking for the least factor. The answer is not 1. Okay. We're just trying to compare the two patterns and see if we see a pattern. Okay. In this case, the pattern was easy. It just incremented by 1. Okay. There might be other patterns stuck in there. I don't see any other ones, but they might be there. Okay. So this is just patterns. This is counting. This is observation, right? And in the ways it's multiples, because we're getting multiples of 3 for A and we're getting multiples of 4 for B. But we're basically not doing anything else with those multiples, just comparing the two of them. Okay, so we already know no matter what, we need to write an expression because that's just staring at me. Okay, and past exams that I'm pulling this from, they didn't give this. It said inside of it like this, what expression, or write an expression. Now they're actually giving you a prompt to do it. Okay, so that's kind of both good and kind of both bad. Okay, so Mr. Jackson orders lunch to be delivered to his workplace for himself and some other co-workers. The cost of lunch, let's see, cost of lunch is $6.25. Okay. There is also a one-time delivery fee of $3.50. Okay. What expression could Mr. Jackson use to find n? So if you're getting one lunch, it's $6.25. If you're getting two lunches, it will be $6.25 times 2. If you're getting 3 lunches, it will be $6.25 times 3. So if n is the number of lunches, right, and there's an implicit times 1 for this one, then our expression is going to be 6.25 n times n, right? We could do that many ways. You could put a dot there. You can put a paren here, right? You can put an x there. In any event, we're getting 6.25 n. Okay, we can write it this way. We write it backwards, n 6.25. That doesn't always work because your symbol name may have been n6. So we don't normally want to do that. If we did it that way, we would do n times 6.25 or n dot 6.25 or n x 6.25 and so on, okay? Right, so it says write an expression, not an equation. So if I said C equals here, I would actually lose the points for actually getting the algebra correct. So it's not asking for anything. I can do it down here, or I show my work where I'm going to say cost of lunch or something like that. So now finally it says use your expression to find the cost of 5 lunches. So it's actually 6.25 n plus 350. Okay, so I have to get that 350 adding onto here. Okay, 5, 7, 4. Okay, that's our answer, 34.75. So it's always worth going back to the problem and rereading it and making sure what you're doing. So this should have been the expression, and this should be the answer, okay, once you apply that. And by the way, this models the equation of a line, y equals mx plus b. This is our y-intercept. No matter what your order is, it starts out at 350, and then it's your slope. 6.25 is going to be your slope, and then that's your x, whatever your x is. All right, so for 1, it would have been 6.25 plus 350. For 2, it would be 1250 plus 350, and so on and so on. You could actually plot that out if you want. If that was 0, 0, we'd get 1 about 9. We get 2 about what would that be about? Well, it's going to start at 3. It's going to start at 350 here, and then from that point just go up. So that would be our thing. They're not asking us to do this, but I'm throwing that in there for anybody who's so inclined to figure this kind of thing out. This is a standard equation that's going to come up for a lot of you guys in a lot of scenarios for the next few years in many different ways. So that's 44. Okay, 45 is a nasty one. Most students got this wrong. This is probably the most erroneous question. So I think I'm going to spin this one out as well. So we have, I think it was the first one. I might spin them separately or together. So let's see, that was 45. And is this the last question? 46 might be the last question. Yes, it was. Interestingly, this one is worth more than all the others were. And to me personally, I find it easy. So a store sells 2 different packages of glue sticks. A at 18 glue sticks per package and B at 12 glue sticks per package. Write an equation, so this does have an equal sign, it's not an expression, for package A, and an equation, again it has an equal sign then, for package B that represents the total number of glue sticks, G, and P packages. So it seems to me like we just did in the previous example, using, let me go back to it. I don't remember it anymore. Where it was the 6.25N. So the price times the number of lunches. We're going to do that same kind of a thing here, except using whatever units are in respect of here. All right. So each package has 18 glue sticks for A. So it's 18 times the number of packages, and then the number of glue sticks is G. So G is equal to 18 times P. And for B, G is equal to 12 times P. Okay? And run it through, use test numbers. If I have one package, right, the number of glue sticks is 18. 18 times 1. Right? If I have 3 packages, 18 times 3 is 54. Again, that's a number you guys should know. This comes up often. Okay? Same for package B. If I have 3 packages, then don't I have 12 times 3, 36 glue sticks altogether? So that's G, right? Read it through again. It represents the total number of glue sticks in P packages. All right? And if you end up getting that wrong, use the test numbers. Do the experiment to see if you have it right. Enough students might say P is equal to 18G here. Well, run it through with the words, right? Represents the number of glue sticks. Well, if I have 2 glue sticks, then do I have 36 packages? No. The opposite is true. If I have 2 packages, I have 36 glue sticks, right? So, or if you don't like working at 18, test it out with the 12 one. All right. So those are you're going to get the points for that. By the way, this is probably why this is worth more. Okay, what I don't like with some of these, though, is the next part down here. If you get the first part wrong, then there's no way to get the rest of the part wrong. So these are kind of all or none questions, which could arguably be unfair. So Mr. Davis buys 5 packages of A. So he does G is equal to 18 times 5. Okay. And Mr. Wilson buys 8 packages of B. So for B, so we can kind of, for A, got that. For B, G is equal to 12 times. So this should actually be 8. So 12 times 8, you guys should know, is 96. 8 times 2 is 16. Carry 1, 9. Again, you guys should memorize this. It's asking for the difference. Okay. So we're going to get 96 minus 90 and get 6 out of that. All right, y'all. That's the last problem. Yes, it is. All right, I'm going to do 2 more streams. I guess for those 2 other questions, they seem to deserve it themselves. Please like, please subscribe. Got any questions? My email's at the bottom. All right. Peace.